One college class had a total of 75 students. The average score for the class on the last exam was 83.7 with a standard deviation of 4.2. A random sample of 35 students was selected. First, we want to calculate the standard error of the mean. So here is the information that was given to us in the problem. As you can see, there is a finite number in our population, meaning that it's not a never-ending a never-ending population. It's 75. So we need to compare in the sample to the population. And so 35 compared to the population of 75. And the reason we're doing this is to see if we need to use a finite population correction factor. So 0.47 is definitely larger than 5%. So when it's larger than 5%, we're going to use this formula for the standard error of the mean. Let me see if I can move it up. So we can look at it and plug in our values. Alright, so here the standard error of the mean takes a little bit more time to calculate just because the formula is longer. So it's still the standard deviation divided by the square root of n. That part has not changed. But this is the extra part, times the square root of the population sample size minus the population size minus the sample size over the population size minus 1. So that's going to be 40 divided by 74, and it's the square root of all of that. So if you do that first, the square root of 40 divided by 74, you get 0.73521, a very long number. I'm just going to leave it like that, and then I'm going to times it by 42, and I'm going to put parentheses around that, divided by the square root of 35. And so your standard error of your mean here is going to be 5.22. Now everything else after this works the same way. It's just that first part that takes a little bit longer to calculate. And obviously I forgot my decimal here for my 4.2, so let me fix that real quick. So the square root of 40 divided by 74, and then I'm going to times that by 4.2 divided by the square root of 35. And so my standard error of my mean is going to be 0.52. Okay, from here on out, you're going to do the same thing. You're going to get your z-score using the same formula. The formula for your z-score doesn't change. The only part that is different this time is the finite population correction factor addition. But once you get to your standard error of your mean, you work it the same way as the other problems. Let me know if you have any questions.